Okay, Wildcats, today we're at journal page 33, solving radical equations. Steps to solve radical equations. Step 1, isolate the radical. Step 2, raise both sides of the equation to the power equal to the index of the radical. Step 3, solve for the variable with simplifying, box method or FOIL or factor. Step 4, check your answer or answers. Okay, if you would, complete your notes. Now your notes are completed, let's take a look at the examples. Okay, solve the radical equations below. So step 1, we need to isolate the absolute value, or isolate the radical, not the absolute value. What am I talking about? Radical. Very radical idea. Okay, so we're going to divide 2 by both sides. So that's the square root of x plus 1 equals 7. Now that the radical is isolated, we're going to square both sides. Now, the squared unsquare roots this, you're left with x plus 1 equals 7 squared is 49. Okay, subtract 1 from both sides. X equals 48. Okay, now we need to check our answers. But check, we're going to substitute 48 back into the original equation. So that's 2 times the square root of 48 plus 1 equals 14. Okay, 48 plus 1 is 49. Okay, so you have 2 times the square root of 49 equals 14. Well, the square root of 49 is 7. 7 times 2 is 14. So 14 equals 14. So this checks. Okay. All right, example 2. Okay, so we need to isolate the radical. So we're going to add 15 to both sides. So that's 5 cube root of 4x plus 3 equals 15. We're going to divide 5 by both sides. So the cube root of 4x plus 3 equals 3. Now we need to cube both sides. Now the cubed uncubed roots of that, so we're left with 4x plus 3, and 3 cubed is 27. Now we're going to subtract 3 from both sides is 24. 24 divided by 4 is 6. So x equals 6. Okay. Now to check, we're going to substitute 6 back into the equation and see if it is true. So that's 5 times the cube root of 4 times 6 plus 3 minus 15 equals 0. Okay. Well, 4 times 6 is 6, 12, 18, 24, plus 3 is 27. So that's 5 times the cube root of 27 minus 15 equals 0. This cube root of 27 is 3. 3 times 5 is 15. So 15 minus 15 equals 0. Well, 0 equals 0, so it checks. Okay. All right, go ahead and finish up example 1 and 2. All right, let's take a look at example 3. Okay, so here we need to isolate the radical, but there's no way to do it because if we divide by 5 here, then that's not isolated, so there's nothing we can do there. Okay, so what we need to do is square both sides to get rid of the square root. Now, this unsquares the square root, so you're left with 35 equals, now this is 5 parentheses x plus 2 to the 1/2, because that's another way to write the square root. But since you're squaring it, you have to multiply it times itself twice. So 5 times x plus 2 to the 1 divided by 2. Okay. So then that's 35 equals 5 times 5 is 25. Now, when you multiply x once you add up, so 1/2 plus 1/2 is 1, so that's x plus 2 to the 1. So then we have 35 equals, we're going to distribute the 25x, so 25x plus 50. Okay. Add another line there. Now, if you subtract negative 50 from both sides and divide by 25, you have x equals negative 15 divided by 25. Okay? Well, that reduces to be negative 3 divided by 5. Okay? So now we need to substitute this in to check to see if it's correct. So then that's the square root of 35 equals 5 times the, I'm going to add another line here. Okay, square root of negative 3 divided by 5 plus 2. Okay, so then here we can make that 2. We need to make it with a denominator 5, so we need to multiply this by 5 divided by 5. Okay, so then that's the square root of 35 equals the square root of negative 3 divided by 5 plus 10 divided by 5, which then that's equal to this. Oh, almost forgot 5 times. Can't forget that 5 times. The square root of 35 equals 5 times the square root of 7/5. Now, this one is the one where you want to use a calculator to check that. So what we're going to do is going to go to calculate. Okay. Let's delete this here. Okay. And then we're going to do control square root of 35. And then we're going to do 5 times the square root of control divide 7 divided by 5. And you can see here the values are the same, so it checks. So you can say 5.91 equals 5.91, so it checks. Okay. All right, example 4. Okay, so again, you want to isolate the radical, but there's nothing you can do with the 2, so you're just going to have to cube both sides. Okay, this uncubed roots that, so you have 1x plus 6 equals 2 times x minus 1 to the 1/3 times 2x minus 1 to the 1/3 times 2x minus 1 to the 1/3. Okay, so then that's 1x plus 6. Well, 2 times 2 is 4, 5 times 2 is 8. And then 1/3 plus 1/3 plus 1/3 is 1. So that's 2 times x minus 1 to the first power. And I think we might need to add an extra line on here. Okay, so then that's 1x plus 6 equals 8x minus 8. We're going to subtract 1x from both sides. Okay, and add 8 to both sides. Okay, so the x's cancel. You get 8 plus 6 is 14 equals 7x, and those cancel. So x equals 2. Okay, now we're going to check by substituting 2 back into here. So that's the cube root of, we can actually do it this way too. 2 plus 6, and we can do 2 times the cube root of 2 minus 1. Now, 6 plus 2 is 8. The cube root of 8 is 2. 2 minus 1 is 1. The cube root of 1 is 1 times 2 is 2. So this checks. Okay. All right, let's look at example 5. Okay. Now here, we're going to square both sides. Now, the square unsquare roots that, so that's 1x plus 18, but then this is x minus 2 times x minus 2. Okay, so then that's 1x plus 18 equals, now we need to FOIL this. X times x is x squared. I guess I put a 1 there, 1x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. And negative 2 times negative 2 is a positive 4. Okay. Now we need to subtract 1x from both sides. And subtract 18 from both sides. Notice how I'm keeping the x's with the x's and the constant with the constant. Well, that cancels. You're left with 0 equals 1x squared minus 5x minus 14. Okay. And yeah, I might need to add another line here. Okay, so we need to factor this. 0 equals, we know it's going to be 2 parentheses. Okay, we know x and x makes x squared. Now we need to find all the combinations that make negative 14 and combine to be negative 5. So we know 1 times negative, 1 times negative 14 is negative 14. Okay, 1 minus 14 is negative 13. Okay, and then we know 2 times negative 7 is negative 14. Well, 2 minus 7 is negative 5. This is our combination, so 2 and negative 7. Okay, so x plus 2, x minus 7. So you said x plus 2 equal to 0 and x minus 7 equal to 0. So x equals negative 2 and x equals 7. Okay. Now we're going to need to check both values. Okay. So let's first check x equals negative 2. So that's a square root of negative 2 plus 18 equals negative 2 minus 2. Well, negative 2 plus 18 is 16. Square 16 is 4. Does not equal negative 4. That means that this is not a solution, or what we call it's an extraneous solution. or abbreviate EXT. It's an extraneous solution. Okay, now let's check 7. So that's the square root of 7 plus 18 equals 7 minus 2. Okay, so 7 plus 18 is 25. Square root of 25 is 5. 7 minus 2 is 5, so this checks. Okay. And let me just come up here. I put EXT, but let me just notate what that means. EXT represents extraneous solution. Now, extraneous solution is a solution that when solved for, you get a value, but when checked, doesn't check. Okay. All right, let's take a look at example 6. Okay. Now, we're going to square both sides. Okay. Now, the square unsquares the square root, so that's 2x plus 14 equals, now we square that x plus 3 times x plus 3. Okay, so then you have 2x plus 14 equals x times x is x squared. X times 3 is plus 3x. 3 times x is plus 3x. And then 3 times 3 is 9. Oh, that was a terrible line. Let's try that again. Okay, now we're going to subtract 2x from both sides. And we're going to subtract 14 from both sides. So then you get 0 equals 1x squared. 3 and 3 is 6, minus 2 is plus 4x. And then 9 minus 14 is negative 5. Okay. So then we're going to factor this. And we know 0 equals, it's going to be 2 parentheses because it's squared. We know x and x makes x squared. Now we need to find all the combinations that make negative 5. So we know that negative 1 times 5 is negative 5. And negative 1 plus 5 is 4. So there's our combinations. Negative 1 and 5. So x minus 1 and x plus 5. Okay, so we said x minus 1 equal to 0 and x plus 5 equal to 0. So add 1 to both sides, x equals 1. And subtract 5 from both sides, x equals negative 5. So now let's check. Now let's start with checking x equals 1. Okay, so I'm going to plug that in. So that's the square root of 2 times 1 plus 14 equals 1 plus 3. Well, 2 plus 14 is 16. Square root of 16 is 4. 4 equals 4. This checks. Okay, so far x equals 1 is a solution. Okay, so now let's check negative 5. So square root of 2 times negative 5 plus 14 equal to negative 5 plus 3. Okay, well, that's negative 10 plus 14 is 4. Square root of 4 is 2. 2 does not equal negative 2. So x equals 5 is an extraneous solution. Okay. All right. Example 7. Okay. So here, because we have the, let me erase some of that so you can see it. The 1/3, we're going to cube both sides. Now, when you cube here, you multiply, so that becomes 3 divided by 3, which is 1. So you're just left with x plus 5 to the first power equals 3 cubed is 27. So then that's just x plus 5 equals 27. Subtract 5 from both sides, x equals 22. Okay, so now we're going to check x equals 22. So we plug that in, so that's 22 plus 5 to the 1/3 power equals 3. Well, I can rewrite this as the cube root of 27 equals 3. The cube root of 27 is 3, so 3 equals 3, and it checks. Okay? All right, last example. Okay, we're going to need to square both sides. Okay, so then you get 1x squared equals, now, again, when you square, you multiply this, so this becomes 1/2 times 2, which is 2 divided by 2. So this is x plus 12 to the first power. Okay, so then you get 1x squared equals 1x plus 12. We need to subtract 1x from both sides and subtract 12. So you get 1x squared minus 1x minus 12 equals 0. Now, you're going to factor. We know x and x. Okay, makes x squared. Now we need to find all the combinations that make negative 12 combined to be negative 1. So let's start with 1 times negative 12 equals negative 12. And then 1 minus 12 equals negative 11. That doesn't work. Okay, 2 times negative 6 equals negative 12. 2 minus 6 is negative 4. That doesn't work. 3 times negative 4 is negative 12. 3 minus 4 is negative 1. That combination works. Okay, so we have x plus 3, x minus 1. Set them equal to 0, so x plus 3 equal to 0, x minus 1 equal to 0. So x equals negative 3, x equals 1. So let's check. Let's start with x equals negative 3. So negative 3 equals, and I can rewrite this as the square root of negative 3 plus 12. Okay, well, that's 9. Square root of 9 is 3. Negative 3 does not equal 3. So this is an extraneous solution. Okay. Now, I should have been doing this the whole time, but I really should have put x equals on the other ones to check. But you don't have to. Okay. So x equals 1. So 1 oh, wait a second. That's a mistake. This should be x minus 4. I almost made a mistake. So then you add 4 to both sides. X equals 4. So check x equals 4. So 4 equals, and you can do it this way too, 4 plus 12 to the 1/2 power. 16 to the 1/2 power is 4, so 4 equals 4, and this checks. Okay? So with that, if you would finish up and start your assignment, have a wonderful Wildcat day.